Okay, this is our circle lecture. Lesson 1. And I'm recording this on Wednesday, the 25th. Obviously a snow day today, and with the weather, we're going to have snow days probably Thursday and Friday. So to keep on the timeline, we really want to try to keep on pace. This is going to be Chapter 12, Lesson 1, and on Thursday, that would be tomorrow, we're going to do Lesson 2, and then on Friday, we're going to do Lesson 3. Okay, so 12.1, 12.2, and 12.3. Note, by the way, when we come back on Monday, yes, the weather will be fine on Monday. You're going to be taking the AccuPlacer test. So the other thing you have to do while you're sitting at home over the next 3 or 4 or 5 days is to review the algebra on the AccuPlacer test. And all of this is on your class page. And if I pull up a copy of your class page, so we see the AccuPlacer test information. You can look at that. Please read the letter, look at the questions. And you can also see the circle information here, if that will pull up. Maybe it doesn't like that. Okay, so the circle information is another topic. In there, what I've done is I've scanned in lessons 1, 2, and 3 for some of you that have not taken your book home. John Durkin, you left your book in class. I used yours to scan in the material. I've also put on there the teacher's guide for lessons 1, 2, and 3 out of chapter 12, and the teacher's guide has all the solutions. So when you work the exercises over the next 4 or 5 days, you can look at the solutions to the various exercises, and that should help get you through this material. Again, we come back on Monday. The AccuPlacer test will be in the computer lab, and then we'll have on Tuesday, I'll plan on a little bit of just an overview of lessons 1, 2, and 3. You are going to be working these at home, of course. And then on Tuesday, after a short review and overview, we'll pick up with circles, section 12.4. Okay, so that's the plan. Lots of work to do. I would guess a half an hour a day for sure, but also look at the AccuPlacer material because you will be taking that placement test for Algebra 2 when you come back on Monday. I should ask, or should mention, that if you have any questions on any of this material, feel free to email me or message me or Mr. Melson, and we should be able to get back to you and get you sorted out. Okay, so that's the overview. Let's go ahead and look and see what's in Lesson 1. I'm going to try to break this one up, or break up these 3 lessons into 3 different videos. So Lesson 1 is a little bit on circles, radii, and chords. Certainly what you should do is look at the text. And remember, if you didn't bring it in, I scanned it in. It's on your topic page, pages 484 and 485, just those 2 pages, 484 and 485. Read the definitions. There's a handful of definitions, and there's 3 theorems. Look at the pictures. Look at the pictures. And then after you've done that, come back. You can pause this little video right now. Let's see, where are we? We're sitting at the 4-minute mark. Okay, so you could pause it and then come back and pick up this video. Okay, so now we're back. You've looked at the book, circles, radii, and chords, and again, it's pretty self-explanatory. I don't know that there's a lot of information here that you haven't seen before, but let's just go through it quickly. We have a point in the plane, and there's an infinite number of points that are the same distance away. So let's say this distance happened to be 3 inches. Well, how many points are 3 inches away? If we're in the plane, there's an infinite number of points, and they form a circle around the center. So we have the center of the circle, and then we have the points themselves, all of these points, infinite number of them. This consists of the circle. So when you look at the definition, it says A circle is a set of all points in a plane that are a given distance, whatever the distance might be, 3 inches or 10 meters or whatever, from a given point in the plane. The given point is the center, right? And the points that are away from the center, those are the points of the circle, okay? Definition, concentric circles. If we have a point and we have a circle, say a blue one that's 2 inches away, it doesn't quite look like a circle, Joe, but we'll make it a little bit rounder. Okay, a circle that's 2 inches away, and then we have another circle that happens to be 3 inches away, and let's say we have a third circle that happens to be 4 inches away. So if all of these circles have the same center, so this might be 4 inches, this might be 3 inches going out to here, and this might be 2 inches going out to here. If the circles have the same center, they're said to be concentric circles. Okay, so you saw that, not a difficult idea. Let's see. By the way, if you look at the definition, you see that if and only if. So circles are concentric if and only if they lie in the same plane and have the same center. Okay, the next definition had to do with the radius and a radius of a circle, two different ideas. A radius is defined as a segment joining the center of the circle and any point on the circle. So this segment is called a radius. And obviously, because there's an infinite number of points on the circle, there are an infinite number of radii, radii being the plural of radius. Radii. Okay, so segment is a radius. Now, if we talk about the radius, that refers to the length of the segment. So this is going to be a number. Length of a radius is called the radius. So when we talk about the radius, that is a length, that is a number. So a slight distinction there, but you should be able to keep them straight. When we talk about a radius, we're talking about a segment, say from C to A. So segment CA is a radius. Segment CB is also a radius, right? All of these segments, CD is a radius. There's an infinite number of radii. But if we talk about the radius of this circle is the length of any one of the infinite number of radii. Say the length of CA, the length of that segment. And that might be a number. Again, just to use inches, that might be 4 inches. Okay? There's a couple of ideas that go along with this. The first one is that all radii of a circle are equal. So these infinite number of radii, right, all these radius segments, they're all the same length. Makes sense because the points on the circle are equidistant from the center. So that makes sense. The next idea is a chord, C-H-O-R-D. Let me pull up a new screen. So here's our circle. Here's the center, chord. A chord is a segment. The endpoints of the segment are on the circle. So that's a chord. Okay, chord. The two endpoints have to be on the circle. That's the chord. Look at the definition and you'll see that. Now, obviously there's lots of different chords. Any 2 points that lie on the circle will create a chord. There is a special one, however, if the line segment passes through the center. It's still a chord, right? This is the center here. And the line segment is passing through the center of the circle, but the endpoints of the line segment are still on the circle. So this is still a chord. Okay, but now it's a special type of chord. It's called the diameter. So when you read that and you see that a diameter, by definition, is a chord that contains the center. So, and again, we sort of have the same idea with the radius. There are an infinite number of diameters, right? So any line segment that goes through the center is a diameter. So I've drawn 3 different diameters here, right? They're all passing through the center. But when we talk about the diameter, it's like when we talked about the radius, that would be a length. Okay, so this circle has an infinite number of diameters, but if I say what is the diameter, I want to know how long it is. So let's just throw a number in here so we can play with it. Let me get a new picture going. Here's our circle. There's the center. Here is a radius. Okay, and here is a diameter. Right, so one particular radius is the segment, a radius, and a diameter, both going through the center of the circle. So let's suppose we said the radius is 3 inches. What is the diameter? Well, obviously twice as much. So here is a radius. Here is another radius. And the center is in between these 2 points. If this is A and B, we certainly have C is in between A and B. So we can say the diameter is equal to 6 inches, just double the radius. Not a difficult idea. Okay, the last bit we're going to do is talking about various lines through the center and various chords. And the 3 ideas are sort of related. So these are the theorems down on the bottom of page 485. You look through them. Here's the illustration. Circle with the center. And we have a chord down here that's not a diameter. So there's a chord. And then we have a line passing through the center, and it's perpendicular to the chord. So there's lots of lines going through the center, but we want the one that goes through the center and is perpendicular to the chord. So I'm trying to draw this so that this forms a right angle here. Okay, and the theorem says that this line bisects the chord. So these 2 segments are the same length. And maybe we can put some letters in here so we can talk about it. C for center. I usually like to use, whoops, class is almost over, but not yet. I like to use the letter C for center, and then for points on the circle, we'll use A and B. And just so we have an intersection point here, let me call this point right here M. And what we're noting in this theorem, this is theorem 56, if a line through the center of a circle is perpendicular to a chord, it also bisects the chord. So we can say AM is the same as BM, right? This length is the same as this length because we're bisecting. And what else can we say? We can say that the angle, okay, so angle CMB, look for it in the picture, CMB, that's a right angle. Okay, so 90 degrees there, that's a right angle. And I guess that's about all we can say from here. Let's look at theorem 57. If a line through the center of a circle bisects a chord, and the chord's not a diameter, then it also is perpendicular to the chord. So these sort of look like the same idea. Theorem 56 says if the line is perpendicular to the chord, then it has to bisect it. Theorem 57 says if the line bisects the chord, then it has to be perpendicular. So think of the hypothesis and conclusion, reverse the 2, so this is the converse. 56 and 57 are converses of each other. Okay, and the last idea is, again, almost the same picture. So we have a circle, we have a chord, we have a line that's going to be bisecting. So we have to think, okay, so here's the midpoint. Again, I'll label these A and B. Bisecting and perpendicular. So draw a line that is the perpendicular bisector. Remember, we've done constructions on how to make this line. This line must, according to this last theorem, theorem 58, this line must pass through the center of the circle. So wherever the center of the circle is. Okay, so that's lesson 1. Now go back and look at the text again, read it carefully, start the exercises, spend a half an hour on this working through the exercises. Don't get hung up If a problem stumps you, you can go and look at the solutions, or you can just skip it and go to the next problem. I would think that you could get through most of these exercises in 20 or 30 minutes maybe. Okay, I'll stop this little video right here, and the next one that you'll see will be for lesson 2 on tangents.